Okay, these are some explanations that you need for the laboratories in this class. The labs in this class are virtual. You do not have to buy anything. You do not have to do experiments at home. Just look at the pictures in the experiments and do the calculations. All what you have to submit is the data that I am asking for. In this experiment, you are going to determine the density of water. Then you read the introduction, the goals, the materials, and so on, in order to be sure about what or what you have to do in order to determine the density of water or any liquid. Here I'm giving you the data. As you can see, you have here the weight of the empty graduated cylinder. Here you have trial 1 and trial 2, where you have the volume in each graduated cylinder and you have the corresponding mass. What is important in this case? That this mass represents the mass of the water and the mass of the empty graduated cylinder. You are not interested in the mass of the graduated cylinder. You are interested in the mass of the water, so you have to subtract the mass of the empty graduated cylinder to this mass in each case. And after that, you apply the formula, the corresponding formula. The density is equal to mass divided by volume. Then here you have the explanation. You can stop the video at any time and you can understand what to do. But what is important in this case? The number of significant figures that you are going to report. As you are dividing, you are going to take into account the significant figures in the measurement with least significant figures. In this case is this one. 1, 2, 3 significant figures. So you have to report the density with 1, 2, 3 significant figures. Then you will calculate the density for trial 1 and trial 2, and then you will calculate the average. Is density 1 plus density 2 divided by 2. Remember, this is trial 1, this is trial 2. After that, you will go to this table and suppose that the density was 1.039 grams per milliliter. Then you say, oh, the liquid is milk. Then the theoretical value for milk is 1.04 grams per milliliter. Theoretical, I say, because it's the one that is in the table, is the one that was presented by somebody that have made this research. Then, in order to calculate the percentage error, you have to follow this formula. It is clear enough here what to do, and multiply by 100. This is a percentage error. You can stop the video and read everything that I explained here. Then in part B, you're going to see what is the density of a solid but using water displacement. What is water displacement? Well, first you put some amount of water in the graduated cylinder, and after that you introduce the solid. As you can see, the volume raises. The difference between this volume and this volume is the volume of the solid. Then this is the volume. You can determine the volume of the solid using this formula, and you will put here in the formula for density. Density is equal mass over volume. As you can see, density is mass divided by volume. So let's see how to read the volume. Look at here in number 1. The graduated cylinder has a capacity of 20 milliliters, but between 0 and 10 milliliter you have 10 marks. Sorry, 20 marks. So 20 milliliters divided by 20 marks represents, every mark represents 1 milliliter. Then you come here and you say the liquid has 1, 2, 3, 4, 5 milliliters, yeah? But what happened here? That in this case you have to estimate an extra digit. So as it is sharp here, you are going to say that the volume is, for example, 5.0. Maybe somebody will say 5.1, anything, but the difference is in the tenth. Well, you will do the estimation of the volume here in the second figure, and then you will subtract the volume and you will get the volume of the solid. The mass is here, no problem with this. Remember that in order to determine the density, you have to divide mass over volume, and you have to apply the rules for significant figures in division. Well, then you come here to the report. This is what you have to submit. The density of the liquid in trial 1, trial 2, and the average. The temperature that was clear enough in the graph. And here you will say the liquid is milk or whatever it is. And you will type here the percentage error. And for the second one, you will say the volume of the solid is, then you will write here the volume of the solid with the correct number of significant figures and the density of the solid that you have determined. Knowing this, you go to the table again and you will say according with this value, the solid will be corn, body fat, ice, muscle, sugar, bone, salt, aluminum, iron, copper, any one of these, according with the result that you get in this formula. After that, you come here and study the rules for significant figures. You can stop the video and you can read it. And finally, you apply the rules for subtracting, adding, multiplying, and dividing. I'm going to explain only dividing because density in this case is a division, mass over volume. Suppose that this is a mass and this is a volume. Oh, the volume in this case has the least significant figures, 1, 2, 3. So in your answer, you are going to report 1, 2, 3 significant figures. As the first number you are going to skip is 7, is higher than 5, then you round up. Stop the video and see the rules for the math operations. Well, I'm going to stop in to explain how will you determine the volume of the liquid? Well, between 70 and 50 you have 20 milliliters and 10 marks. You divided 20 milliliters by 10 marks, and then you say that every mark is 2 milliliters. So the digit, the extra digit, will be in the units. You can say, for example, that this liquid is 90 2 4 6 8 100. Then it's 100 milliliter. This is what is the reading. You only can say that is 100 or 102 or 98. This is the place that you will estimate is in the units for this case. But in this graduated cylinder, oh no, look at this. Stop the video and read all the information, and then you will see that in this case the volume will be 4.1 because every line here is 0.1 milliliter. And you have to estimate an extra digit because as the line, every line is 0.1, you have to estimate an extra digit. Then the extra digit will be in the 100. Then you can say that the volume is 4.10, but other students will say 4.11. Both are correct because the last digit is always estimated, depends on the person that is doing the measurement. But what you are sure is that your answer must have 1, 2, 3 significant figures, 1, 2, 3 significant figures. Stop the video and try to see what to do in measurements, significant figures, and significant figures in math operation. If you have any doubt, just let me know, and remember that every Tuesday at 8 o'clock you will be with me, or I will submit a video like this in order to explain the experiment of every week. If you have any question, send me an email telling me the questions, and then I will answer you in the video that I will prepare for you. Thank you very much.